Hey everyone, today we have two fresh speakers, Ben and Gabi. Guys, thanks a lot for volunteering to do this talk. So we're always looking for passionate speakers. So their presentation is about account abstraction. This topic has been around for a while, but many say that it's still crucial for Ethereum UX. So that's about it. So Ben or actually Gabi, you go first, right?
The first one will be Ben.
Cool.
Okay, just everybody, if you could hear me.
Yes, we see your screen.
Yes.
Fantastic. So I'd like to welcome everyone to today's discussion on account abstraction, solving web3 UX to the masses. And the topic of account abstraction has been given many kind of phrases. Some people will say it is giving people access to self-custody. Some say it's UX to self-custody. You hear different kind of phrases and monikers. There's also a lot of discussions about changing the phrase itself, account abstraction, which you can imagine is a mouthful, and making it something simpler. So just a very simple introduction of myself. I am a CEO and co-founder of a startup called AutoRent. We can talk later about it. And I'm specializing at the moment more in the decentralized real estate field, but also with a strong emphasis on smart contract security because of the amount of financial investment involved, and account abstraction because of the problems with automation and easy access to anything to do with real estate. So I have about 6 years of Solidity development. So that's enough about me. That's an older picture of me. Without the beard, that's a cleaner version of me. So this is really what we're going to look at today for. This is some of the projects I'm involved in. If anybody later wants to comment, this is more specific to the account abstraction projects. I'm writing 2 books. The idea started out writing 1 book on general account abstraction, but as Gabi and a lot of people who have dabbled into this, so much technical know-how needed to safely and successfully implement account abstraction. I'm now having to write a technical book side by side with a general book. So if you're interested in writing, come and join me. If you want to write a chapter, that's always a great idea. I'm also doing some work on relayers. If anybody knows anything about relayers, the bundles are trying to replace the relayers. Gabi will go into a little bit more about what bundles are later. I won't touch too much on it, but I'm trying to introduce account abstraction into relayers. And the one I'm focusing on at the moment is the wormhole relayer, mostly because of the security concerns they've had recently, if you've been up to date with what's happening in terms of the hacks within the field. And then also my own startup, easier UX UI interface for people to access the platform and to help increase functionality for the smart contracts in terms of monetizing their rent deposits. So those are 3 projects. So if you want to get involved with me, if you want to collaborate, if you want to join an open source, you're more than welcome. So this is the agenda for today. We're going to look at an introduction. It's going to be very high level. And after this, we're going to have some subsequent discussions about account abstraction. So we're going to gently progress it from high level, and then we're going to get a little bit more technical. So today is just a very good overview. So I do apologize if anybody is quite conversant with account abstraction. This may not be the best format for you, but it's a good reminder, like a concretizing of the foundation principles. So an introduction, we're going to look at the history. The history of account abstraction is very, very critical to understanding where we are today. The history is going to be more of the history from an Ethereum basis, but it's also going to parallel what was happening side by side as people are trying to implement account abstraction into the Ethereum blockchain and what other blockchains like Avail and zkSync, and Starknet, and Near have tried to implement. Won't go too much in depth into, but just a little bit of the history. And then jargon. Jargon is going to be just some of the popular terms you'll come across, which may confuse you, which may bamboozle you at some point, but you just give a rough idea. People are talking about the same thing. So what is account abstraction? Just take a moment to think about what is an account. We're talking an account more from a blockchain perspective and what abstraction means. Most of us are conversant with what an account is. we've either used an externally owned account, which is just a big phrase for a wallet. So if you've used the MetaMask, you've used the Rainbow, you've used the Coinbase wallet, Safe Wallet, Argent, Ambaya, the list goes on and on and on and on. You must have used an externally owned account. And externally owned account has some very unique features. Public-private key pair, so you need a private key. You have some kind of seed phrase, could be 12 words, could be 24 words, as the case might be. Has some kind of nonce involved, and there's some kind of signature model system. Signature to verify transactions, to send transactions. So your classic example would be a MetaMask. That's an externally owned account. Smart contracts account can be confusing, but it simply means just a smart contract. And if you've written smart contracts in Solidity, if you've written in Viper, if you've written in terms of another language like Flow or Move or on Avail on the Solana blockchain, it simply means the logic that is embedded into your smart contract and what functionality it gives. Now you can see the externally owned account word is equated to the smart contract account. So try and think, what does that imply? Well, it simply implies that the ultimate goal of account abstraction is to look at the functionality that externally owned account has. So let's use MetaMask as an example. Think of the functionality, what you can do with it, some of its limitations, and can we take some of that functionality and put it into a smart contract? So if you write some Solidity code or some code in Viper, or it's on the Flow blockchain, on the Move blockchain, can you take some of the things I can do with my MetaMask wallet and let my code do it? And that will get all of us thinking. We'll get thinking now because we think, what can I do with my MetaMask account? What are the things I can't do with it? What are the limitations of a MetaMask account? What are the limitations of a smart contract? All these are critical to understanding why the push for account abstraction is coming. And the long-term goal, just in a nutshell, if you don't remember anything from this presentation, the long-term goal is to eliminate externally owned accounts, make them deprecated, make them defunct, make them obsolete, and to move the functionality to something called the smart contract account. So let me give you an example that will help you think about it. Think about the difference between a horse for transportation and take, for example, a very old car model. Let that sink in. A horse has some advantages over the car, and the car has maybe more advantages over the horse. But think about how limited they both are in terms of the advantages. Think about how limited the advantages of the engine, of the steering wheel, of the tires. And if you're somebody into sci-fi, you've seen sci-fi movies, you've seen crazy things that cars can do there. Well, the new type of smart contract account is looking to make the functionality of our MetaMask, how we sign transactions, how we verify transactions, how we send messages, how we store tokens, how many kind of signatures, the kind of cryptographic signature algorithm we have in there to become like a self-driving car. So imagine a self-driving car, what you can do with it. That's really what the goal is. Now, this slide here is very critical. Take a while to look at it. If you needed to onboard someone today in blockchain, 8 processes are involved to onboard the person. Contrast that with, for example, how easy it is to open an email, how easy it is to maybe use your iPhone, how easy it is to maybe use your WhatsApp account. 8 distinct processes, and there are perils at every stage of the process. And think about 3 kinds of customers you might meet in the blockchain field. Take, for example, we have ETHCluj, or maybe ETH or ETH Constanta, as the case might be, or ETH Cryover. Your friend is keen to come to one of these events. You've been talking about web3 all the time. How do you get him to sign up for this event if the organizers insist on paying by ETH? What if the organizers insist on paying by USDC? What if they insist on paying by, say, the Chainlink token? How do you get him to sign up for this event? These 8 processes is what your friend would need to go through just to be able to sign up. Contrast that we're going to watch a movie at the cinema and how simple it is compared to just going to this event. So that's one customer that would have to go through this whole process of extending the account. Another one could be someone that, for example, an older mom, a grandmom, an uncle, maybe Facebook is now centralized, want to go to decentralized social media. So you brought up this great idea for this decentralized social platform. And your mom wants to come on board, or your grandma wants to come on board. With the current blockchain method, she had to go through these 8 processes just to have access to the blockchain. MetaMask, download onto the browser extension, 12-word seed phrase or 24 seed phrase, store it somewhere, 3 copies, hide it somewhere, and so on and so forth. And the last customer example you can think about is, for example, you build an NFT, people want to come on board, and now you don't want them to make the initial payment. Say, for example, you bypass the other 2 processes. You say, okay, I will find a way to make the token payment for you, initial token transfer for you, because it costs gas to come on board. Still the same processes somebody's got to go through, at least 6 or 7 of these processes. That's the challenge where we are in terms of web3 and why the demand for account abstraction is really being pushed. So that brings us really nicely into where we are and where we would like to go to. All the information in red is the limitations of extending owned accounts. Some of them we've spoken about. And all of us, to some degree, might have lost some tokens, or know somebody's lost tokens, lost private keys, lost seed phrase, lost accounts, or know somebody who's lost it. Paid too much gas and had transaction reverted. Have somebody had their accounts broken through multi-sig if they just set it to 122 or 123, and so on and so forth. In fact, from England, where I come from, there's always a story on the news of somebody that bought 2 BTC back in the day, or 4 BTC back in the day, when it was, for example, 10 euros or 20 euros, or whatever it was. He can't remember the private keys. He can't remember the seed phrase. He's on the last password 3 times it locks, and he's frantically searching for it. Why? Because of the limitations of the externally owned account, which forces you to have seed phrase, forces you to use a private key pair, and forces you to have certain systems that are coupled into the original account. So account abstraction is looking like a decoupling of the nonce abstraction, the gas abstraction, the key abstraction, the signature abstraction, and so on and so forth. And the list of everything we can remove to have varied functionality. Imagine if we can have different kind of gas model systems, different kind of signature systems, different kind of transaction systems, limit of transactions we can send, limit of transactions per day, per week, specific days, and so on and so forth. That's what account abstraction is trying to tackle with the smart contract wallets. But even in that situation, you can still see it has quite a few limitations. And some of the limitations we still have is that ERC 437 has come very, very late. Now, I'm going to tell you something surprising. And this is the saddest piece of news you will hear today. We could have implemented account abstraction into Ethereum in 2016. Let that sink in. Bear in mind, Ethereum started in 2015. So we could have had account abstraction at the native level. But now we're trying to bring it back. But it's hard to get this functionality, and people have lost money, people have lost tokens, people have lost hope in blockchain, Web3, and all kind of disillusionment. So that's the history, as you can see. I'm not going to go into every EIP. Maybe some of them are recognizable to some of you guys. There's been a lot of discussions and movements before we came to ERC 437. In the slide, you can see it's EIP. And does everybody know the distinction between an EIP and an ERC? Well, An EIP means you're working to implement at the protocol level, which means you have to make changes at the core infrastructure of the Ethereum blockchain, nodes, changes to the original code on the EVM, and so on and so forth, and which means these changes must be adopted by all the nodes. So there must be a consensus. That's an EIP. But an EIC means we can work more at the application level. And ultimately, they have to move account abstraction for the Ethereum blockchain to the application level. Now, interestingly, some other blockchains like zkSync, Starknet, and Avail have implemented it at the native level. But that'll be discussion for another time. So now we have these two scenarios. Ethereum operating at the application level with EIC 4337, which I'm going to talk a little bit more about later. And then other blockchains having it directly, like zkSync and Starknet, already. And what it simply means is, remember, all those functionality that we're looking for from the externally owned account to transfer to the smart contract account, it already has it at the blockchain level. You don't need to have anything extra and implement another kind of interface or protocol for it to be implemented into your smart contract. So we've now come to EIP 4337. The whole history moved along, and in March 2023, EIP 4337 was implemented, was released, implemented. They had a smart contract audit, very good audit by OpenZeppelin. And these were some of the goals they had. So obviously to implement account abstraction, non-subtraction, gas abstraction, key abstraction, signature abstraction, and so on and so forth. They looked obviously at trying to look at implement time and gas savings. So instead of sending 1 transaction, 2 transactions, 3 transactions, 4 transactions, and we know there's got to be a verification process on the Ethereum blockchain. If you can send a bundle of transactions in a certain time period, your transactions go through quicker. And obviously you save more gas, because if you're sending 1 transaction, for example, approve this, or token swap, or an arbitrage, or flash loan, or yield farming, you're going to spend gas every time. So that was one of the goals. It aimed to look at consensus preservation, and that's spread out to 2 categories. Consensus preservation, as in, we don't need to go down to the Ethereum protocol. I'm talking specifically on the Ethereum blockchain. We don't need to change the proof of stake consensus, the transition from proof of work to proof of. We don't need to change it. We can just work with the concurrent consensus, and then we can work with it. But also, more interestingly, it means it now gives you the leeway. If I want to introduce a proof of authority into my dApp, a proof of hack into my dApp, a proof of reputation into my dApp, a delegated proof of stake into my dApp, I can work with that and still work with the original proof of stake consensus on the Ethereum blockchain. Obviously, decentralization. A lot of Ethereum is not centralized, as you probably could reckon. A lot of discussions about using cloud computing behind the scenes and Lido and how many are running on centralized cloud computing providers. There's a lot of discussion about that. And it's looking at how we decouple things to get true decentralization, as opposed to having things. And many of you that have heard about a lot of the conversations of whales and how, even though it started out being decentralized, it eventually became centralized because you had big pots of whales coming together and working on a central basis to get the maximum kind of Ethereum and Bitcoin. And also working with new use cases. Use cases, for example, making atomic transactions, having different kinds of signatures. I'll just give you one use case. With the current system we have now, if I'm able to hack your account, I can drain your whole account. And there's not much you can do to stop me. I can drain everything on an externally owned account if I have access to your private key pair or to your seed phrase. And I can drain everything to your smart contract account if I can get some kind of access control or front running or reentrancy attack, and the list goes on and on and on and on. But imagine if I can introduce logic into my smart contract account where I could say, I've written a smart contract logic into my account, and on Monday, the maximum amount that anybody can withdraw, even if it's hacked, is 20 ETH. And the final supply within the account is 1,000 ETH. How secure would that be? How much confidence that would give to the general public and the big players to come in? As opposed to the current system where if you have 1,000 ETH and I get into your account, I'm draining everything. Yeah. Except you have some white hackers to come in and drain at the same time, and that's the best we can do. So that's just one use case of the objective. Now, these are some of the exciting features of ERC 427. I've already touched on some of them, and some of them may shock you. Wallet recovery. How many of us have lost a wallet before? Technically lost an account. I have. Opened the MetaMask account, wherever it is, can't remember the seed phrase, can't remember the password, have 100 euros in there, sometimes 200 euros, whatever it's in there, cannot remember for the life of me. So the account and the key are synonymous. My wallet is the key, and the key is the wallet. So once I use my key, lost my wallet. How to recover wallet through social recovery. Multi-sign transactions, I've already talked about it. I want to send different kind of transactions for different kind of scenarios. So instead of having just one particular kind of signature for a particular kind of transaction, I can have different kind of signatures. The signature currently in place now is the ECDSA, which means every time I use an externally owned account, I can only use the ECDSA. And the ECDSA is very, very backwards in terms of where our current cryptographic algorithm signatures are. There's stronger ones like Schnorrs, like BLS have come along. So if, for example, I set up a system of payments in my company, I can say top earners over 100,000 euros, BLS. Next level, 50,000, I can say Schnorr signature. Next level, I can say, okay, I can have an ECDSA. That will give me a range of signature aggregation I could use for different kind of transaction payments. Obviously, talk about bundling transactions. You send in 1, 2, 3, 4, 5 transactions just to get one outcome. They can bundle that transactions, make one single gas payment. That would be a great idea. Spoke about custom limits. You can limit how much could go out from your account on a daily basis. If it gets hacked, or if there's any danger of any kind of situation, I can just limit it. And that we can implement through ERC 427. And that can sponsor transactions. So remember the earlier situation I spoke about, you have a friend coming to ETHCluj. He ain't got no MetaMask account. He doesn't want to go through the whole rigmarole of MetaMask account. You can delegate that transaction payment to someone else, and they pay for it. He just pays with fiat, and he just comes. He doesn't bother about MetaMask downloading and seed phrase and all that. So that's some exciting features. These are some jargon you may come across. They all mean the same thing. They're just similes in some ways. So you may come across people using the phrase account abstraction, obviously. People use the phrase chain abstraction. Chain abstraction is just looking at how people are working within the blockchain, and it's almost working blind. They don't know any of the workings behind the blockchain. So all the current functionality of having a seed phrase and signing transactions all happening behind the scenes, and they're just using like a traditional Web2 login or Web3 authorization login to come in. And obviously a smart contract wallet. It just gives you all the same functionality of multi-sig, gasless and sponsored transactions, custom limits, two-factor authentication, social recovery, and so on and so forth. And those are some links in case anybody wants to stumble upon any more jargon. So that's me. I have a remaining number for now, so you can call my remaining number for now. And that's my LinkedIn, that's my email, and then that's my Twitter. So if you want to have a further discussion, any questions, feel free to get in touch with me. And then that's my presentation. So thank you very much for listening.
Thank you, Ben. That was a nice presentation.
Thanks, Ben. Before we move on, does anybody have questions?
I do have one short question.
Yes.
So why I'm not sure I understand why, as I saw in your presentation, that okay, so the private key is a single point of failure, but why it would be better to have like the web two-factor authentication things? I'm not sure I understand, like as a security reason.
Okay, that's a good question. The current kind of authentication or authorization methods from Web 2 are centralized. So it's still a centralized argument. So that's a core argument of trying to move away from centralization and decentralization, because Google, WhatsApp, Netflix, any system you're accessing through that Web 2 system, authorization, authentication, they can access your account. Google can shut down your account. It's no difficulty. So that's more of a centralized, decentralized discussion. The current problem we have within Web3 is if you just have one single key to access your account, and if it's not a multi-sig, and you don't have a range of types of keys of implementation and types of signature, that means if you lose that key, then you're limited. And even with the difficulties of multi-sig, even though multi-sig sounds like a great idea, the uptake of multi-sig has not been as popular as people expected. So very few people actually use the multi-sig to access their day-to-day accounts. So even though it's there, it's not actually had a great uptake. That's why giving you now a range of key access systems, so that if you do lose your key and you're not implementing a multi-sig, you can use a social recovery system within ERC 437 to actually recover your key and have access to your account.
Okay, so in this situation, for example, the ledger, the way they recover private keys. If we use something like even less safe, for example, I don't know, Google, to recover our key, isn't this even a bigger point of failure?
Yes. You see, so from the Web 2 situation, it's a bigger point of failure if Google goes rogue. So that's why Safe, for example, has now implemented a Web 2 authorization SDK that is also a Web 2 authorization SDK. It immediately goes from a centralized to the centralized system. So if you have any points of failure with the centralized system, you have the fallback safe of the centralized system. And this is an SDK that Safe has implemented. But long term, we want to try and move away from allowing big institutions, big enterprise to easily access our accounts. And maybe in countries where there's a measure of democracy, it's not a problem. But in countries where there are maybe totalitarian systems, it's really problematic, because they can take control of the systems and easily access your account. And that can be a problem. If I can read your emails on a daily basis, it's problematic.
Thank you for explanation.
You're welcome.
Yeah, if there are no more questions, I can start sharing my screen.
Sure, go ahead. Thanks, Ben. I really liked the way you presented. Easy to follow.
Okay, just 1 second. Okay, can everyone see my screen?
Yes.
Okay. Hi, everyone. I am Vasile Gabriel Marian. I am currently an SDK engineer at Bioeconomy, and I'm focused on improving Web3 user experience through account abstraction. I have 3 years of experience in blockchain development, with a particular focus on DeFi applications. Okay, so like the first thing is, let's see what ERC 437 is. Basically, ERC 437 is an account abstraction proposal which completely avoids the need for consensus layer protocol changes, like Ben also mentioned. Instead of adding new protocol features and changing the bottom layer transaction type, this proposal introduces a new higher layered pseudo transaction object called the user operation, which we will talk about a bit later on. Users will send user operation objects into a new separate mempool. And there is this idea of bundlers, which will package up a set of these objects, which are the user operations, into a single transaction by making a call to a special contract. And that transaction then will be included in a block. Okay, so the main components of 43.7, which I think are the main components, there are many other than these. But for me, it's the smart account wallet, it's the smart account factory, the entry point, bundler, user operation, and paymaster. We'll start by talking about the smart account wallet. So the smart account wallet is a smart contract which aims to do everything an EOA can do, but much more than that. Now, to support ERC 43.7, wallets must implement a smart contract that is required to have two functions. The first one is this validate user op, which takes a user operation as an input. And this function is supposed to verify the signature and nonce of the user operation, check if it can pay the fee, and increment the nonce if the verification succeeds, and throw an exception if the verification fails. Just checking, is my screen visible? I had some internet problems earlier, so.
Yeah, looks good.
Okay.
All good.
Thank you. Yeah, then there is this execute method, which also needs to be implemented on the smart contract account. This will interpret the call data as an instruction for the wallet to take some actions. How this function, it's like written depends on the smart account provider. Like each smart account provider has different implementation of these smart contract wallets. Like, for example, Bioeconomy, Alchemy, Kernel, all of them have different implementations. Once the smart contract has this logic, you can go ahead and implement other custom features like smart account modules, like batch execution of user ops, different signature schemes, and more. Now, having so much freedom of implementation is both good and bad. It's good because you are free to add your own logic and like customize the smart contract however you want. But it's bad because all the smart accounts will not be compatible one with another. And especially this has been an issue on smart account modules, where one Bioeconomy module is not compatible with a module from Alchemy or from Safe or from Kernel or from other providers. If anyone has any question about that, or we can ask questions at the end, I think it's better, right? Or however you guys want.
Guys, if you have questions, just you can also post them in the comment section or in the chat.
Okay, yeah, nice. All right, then let's see what is this smart account factory. So the smart account factory, it's a smart contract. It's different for every provider and is responsible of deploying smart accounts at the counterfactual address, which can be known before the account is deployed. This is the idea of a counterfactual address, is that you know the address of the smart account before it is actually deployed on chain. Now, a smart account will be deployed as soon as it sends the first user operation. A deployed transaction will be batched in the first user operation if the smart account is not yet deployed. In order to deploy the smart account, of course, the smart account needs some funds to pay for the gas. So this is one step an EOA needs to take, is to pre-fund the smart account before it is deployed in order for the smart account to be able to pay for the deployment. This is only viable if the smart account doesn't use a paymaster. If the smart account uses a paymaster, then the EOA doesn't have to pre-fund it. You can also specify an index when deploying a smart account, and this is because we want each EOA to be able to have many smart accounts. So, for example, your EOA could have a smart account address at index 0, and could have another smart account address at index 1, 2, 3, and so on. The maximum number is 2 to the power of 256 minus 1, so it's a pretty big index. Now let's see what this endpoint contract is, and this is one of the most important elements of ERC-427. This is because this bar contract, it's first of all, it's a singleton. It only exists at one address, and it's it's one entry point per chain. So there's no clone of this entry point. This is audited by many companies, and it's a trusted smart contract. This is as I said, this is a consistent address across all the chains. This contract interacts with all the smart accounts to validate and execute the user operations, and it also forwards the gas payments to the bundlers. We will see a bit later how this is happening. I have some diagrams where I'm showing this. The contract provides two main methods. It has the handle ops and handle aggregated ops. The handle ops method will processes user operations for accounts that do not require a signature aggregator, while the handle aggregated ops method will handle batches of user operations from multiple aggregators. This discussion will focus only on the handle ops method. The handle ops function follows up a two-loop process, which is one, a verification loop, and the second one, it's an execution loop. Now, what happens in the verification loop of this handle op method from the entry point is first, create the account if it does not exist. So this is what happens when you execute your first user operation on your smart account. It will check if your account is not deployed or it is. If it's not, it will use a field on the user op, which is called init code. If the account does not exist and the init code is empty, the call must fail. It will also calculate the maximum possible fee the account needs to pay based on validation and call gas limits and current gas values. It will also calculate the fee the account must add to its deposit in the entry point, because every smart account needs to deposit some Ethereum in the entry point in order for the entry point to be able to pay the bundler for the execution. Now, again, if the smart account uses a paymaster, the smart account doesn't need to deposit any ETH. The ETH will be deposited by the paymaster. Okay, next step is to call the validate user op on the account. So this is a method from the smart account, passing in the user operation, the hash, and the required fee. And then to validate the account's deposit in the entry point to check if it's high enough to cover the max possible gas cost. Okay, after this verification loop, in the same function, so in the same handle ops method, we have an execution loop. What this does is it calls the account with the user operations call data, and it's up to the account to choose how to parse the call data and what to do with it. After the call, we will refund the account's deposit with the excess gas cost that was pre-charged, because the gas needed for the user operation is mainly estimated by these 437 infrastructure services, and most of the times will be bigger than what they actually need, and they will return an excess gas back to the smart account. After the execution of all the calls, we pay the collected fees from the user operations to the bundlers, and that's it for the execution loop. This is an execution loop without a paymaster. So yeah, we have discussed about a few elements, the smart account wallet, smart account factory, and entry point. And this is a simple diagram on how they work together. So you see the first step here is to call the handle ops method. This can be called by either the EOA or by the bundler, which this is what typically happens. The bundler is the one that calls handle ops. It calls, you see the second step here, it's to call the create using the init code. This will only happen if the smart account is not yet deployed. So it calls this create method on the factory, which will create an account, which it will return the account back to the entry point. And then the entry point will call the validate user op on the smart account, which will check, does the smart account have enough ETH deposited for this transaction in order to pay for the gas fee. It will also check, is the signature correct? So did this EOA really sign this user operation? So it will recover the address of the signer and check all of these fields. After the validation is done, the account needs to deposit the ETH in the entry point. Then it will deduct the account deposit, which is basically, these are some state changes in the smart contract. And then 8 and 9 is basically the same thing, but for the second account. So after these are done, we deduct the gas for each account. And this is like the verification loop. And then there's this execution loop. And in the execution loop, what happens is the entry point will call an exec method on the smart account. After that is executed, we refund the account the excess gas. And after that, we compensate the beneficiary here, which is the bundler. So let's talk about the bundler and see what it is. So the bundler is a service that tracks user ops that exist in an alternative mempool. And as the name suggests, bundles them together to send to an entry point contract for eventual execution on chain. You can think of this bundle as an executor or relayer, if you know this term better. So essentially what a relayer is, it's a very high level, it's just does stuff for you. It executes some actions for you. So it will be responsible of calling the entry point, and it will initially pay the gas for the user. A bundler is like the core infrastructure component that allows account abstraction to work on any EVM network without requiring any changes to the protocol. Its purpose is to work with a new mempool of user operations and get the transaction included on chain. Now on the right here, you can see this very simple flow of a user screaming for help. So he has this user op and he wants someone to handle it for him. And there comes the executor or the bundler or relayer, however you want to call it. So it will take the user op from the user. It will call the handle op method on the entry point. The entry point will call validate op on the smart account wallet. After that is done and the user op is fine, the entry point will call execute op on the smart account wallet again. And after this is executed, the entry point will refund the bundler for his work. And the user is now happy. Here's another diagram. Again, very useful. You can see here we have a few users. They are all sending user operations. These user operations are sitting in a mempool where they are waiting for a bundler to pick them up. The bundler will create this bundle transaction, which is a normal Ethereum transaction, but contains these user operations bashed inside of it. And this bundle transaction is added in the Ethereum block, and an Ethereum block can have many bundle transactions. Yeah, so we haven't discussed about what user operation is and how it looks. Here it's represented in its core form, a solidity struct. So basically a user operation, it's a pseudo transaction object, which is used to execute actions through a smart account. User operations will be sent to the user operation mempool, as we already mentioned earlier, which is a dedicated high-level mempool specifically for user operations. So instead of going to a traditional public mempool that we all know of, this will, instead of going to a traditional mempool that hosts the pending transaction, it will go to the user operation mempool. Now, these bundlers will listen the user operation mempool and bundle multiple user operations together into a classic transaction. They first verify the validity of the user operations using the relevant entry point methods, which we have already mentioned. The bundler then includes that multi-user operation transaction in the next block, and they propose it to the network. And you can see here what the fields on a user operation are. I can tell you, like, the sender is the smart account wallet address. The nonce is for anti-replay protection, and it's also used in the salt when at first time when the smart account is deployed. The init code, it's used only to deploy the smart account, and when the smart account is deployed, this should be empty. The call data is the data to execute. It can be whatever. The call gas limit is the limit for the execution phase. So like the execution loop that we have discussed earlier about. The verification gas limit is the limit for the verification itself. The pre-verification, this is for the bundler, is the gas required for the bundler to validate and to verify the user of chain. We have the max fee per gas and max priority fee per gas. These are like classic, and they are also present in the like normal Ethereum transactions. Paymaster and data, this is to provide the paymaster address and the paymaster data. And this is typically empty if the user operation is not sponsored. And then the signature of the EOA. Okay, let's see quickly what is a paymaster. So account abstraction wouldn't be complete without the paymaster, which is essentially a smart contract that will deposit ETH in the entry point in the same exact way a smart account will do it. Each AA provider has freedom to customize their paymaster contract however they want, as long as they follow the iPaymaster interface. Now, one of the major challenges of an EOA is that the user has to hold ETH in order to do anything on chain. Well, with paymasters, ERC-4087 allows abstracting the gas payments altogether, meaning someone other than the wallet owner can now pay the gas. One phrase I really like to mention when talking about paymasters is users don't pay AWS fees when they are using Web2 apps, so they shouldn't be required to pay any fees when they are using Web3 apps, if we really want high adoption. How these paymasters work? Well, the main method of the paymaster contract is this validate, this validate paymaster user op, which takes a user operation hash, and a max cost inputs. The entry point will call the paymaster methods when paymaster and data field is not empty for a user op. The validate paymaster user op recovers the signature from the paymaster and data and checks if it's signed by the designated signer. Then if the signature matches, it checks for balances in the paymaster, and if the paymaster has enough balance, the user op will be sponsored. One thing that changes now when we are adding a paymaster in the entry point flow is that we have a few extra checks. So now we call the user op validation method on the smart account wallet, which was also present earlier. But now we also have to call this validate paymaster op on that paymaster, because the paymaster needs to check if it has enough ETH to repay the bundler. Now for each loop, we call this execute op on the user ops sender wallet, tracking how much gas we use, then transfer the ETH to the bundler to pay for that gas. If the user op has a paymaster field, then this ETH comes from the paymaster. Otherwise, it will come from the wallet as before. Yeah, so I will go fast actually into this. Let me see. Yeah, there are just a few slides left. So the ERC20 paymaster, it's very simple. It basically allows a smart account to pay the gas in ERC20 tokens. This is very useful for examples when a user may have 1000 USDC, but he doesn't have any ETH. So he doesn't have funds to pay for even to swap that USDC in ETH, for example. So yeah, the A provider typically uses off-chain logic to calculate the token fees. This process involves like obtaining token codes from third-party sources like CoinMarketCap and ensuring that the fee covers both the gas cost and the additional charge for the paymaster service. The paymaster contract pays the gas in ETH, to the bundler, so it doesn't pay the bundler in ERC20, but it does receive the equivalent value in the ERC20 token. Bioeconomy is an example of an AA provider that offers both sponsored and ERC20 paymaster modes. And this is the diagram included in the paymaster. So you can see we have the validate user op. So yeah, handle ops, then validate user op on account. Then we have this new extra method, validate paymaster user op on the paymaster. And then we deduct the paymaster deposit instead of deducting the account deposit. And in the execution loop, we call exec on the account. And now we need to also call this post op method on the paymaster, which basically does some, like it updates the states with some last changes, like modifying the balances of the paymaster ID and just synchronizing the contract state. And then yeah, refund the paymaster and compensate the bundler. And this is a flow with the paymaster. So as usual, the user doesn't know what to do, so he asks help from the bundler. The bundler will call the handle ups on the entry point. The entry point now has an extra step to validate also the paymaster user op, which is a method on the paymaster contract. The paymaster will refund the Ethereum if this is valid. Entry point will call validate top on the smart account wallet. If this is fine, it will continue with executing the user op. If this is also fine and doesn't revert, then the entry point refunds the bundler with the Ethereum that was received from the paymaster this time, not from the smart account wallet. Yeah, and some last words, some other advantages of ERC-for-GT7. It's important to note that AA providers offer more than just sponsored transactions. For instance, we at Bioeconomy provide various modules, including a session key validation module, a batch session validation module, which batches multiple user operations with one session key account. These two modules basically offer a very nice UX because you don't have to sign now every time you do a transaction on your DApp. So you can pretty much create a clone of Uniswap where you just sign one time when you log in. We store a session, and for 1 or 2 hours you can do anything you want without having to sign for your actions. And yeah, we have other modules as well, like social recovery module, multi-sigs, and much more. Modules are a great feature of AA, enabling the addition of custom logic to smart accounts that can be easily enabled, disabled, or replaced. For example, a smart account could implement a custom module to enforce daily spending limits, like blocking any transaction once the limit set by the user is exceeded. This will be a very nice feature, which even I will want on my EOA. Now, another idea, which I will also want on my EOA, is a module which will be blocking tokens which you have not allowed to be received in your wallet. Because I don't know about you guys, but I have this problem where I receive daily scam tokens and spam tokens, and whenever I want to watch, my portfolio or something on BlockScan, I have a lot, and also my transactions, I have a lot of incoming transactions with random tokens coming to my wallet. So yeah, this is it. I had other slides as well about some EIPs, but I think it's enough for now. We can do another talk later on, maybe next week on whenever you guys want. Also, if anyone has any questions, please let me know.
Yeah, that would be cool. Gabi, I saw you on that slide that you skipped past. So there's also native account abstraction, right?
You mean this
EIP
one?
on that.
This one?
I think so. I don't remember the exact EIP number. 7701. So there was a proposal by May or so. Oh, okay.
Yeah. Yeah, we have there are a lot of things to talk about. There are a lot of EIPs and ERCs which keep coming in, and we can't even like keep track with all of them. But 3074, honestly, it was a good idea 4 years ago when it first came out. But then it got approved, and then a lot of discussions were started about it, and we found out that it's very unsecure and it's not safe. And then this guy that worked on it for 4 years was so happy when it got accepted. But then Vitalik came in, and he proposed this EIP 7702 in like a few hours, and now 3074 may not be included in the next hard fork. Yeah, and EIP like 7702 basically, simply put, is just, it will transform your EOA into a smart contract account just for the time of when you call a transaction. So it will transform your EOA into a smart contract account by deploying some contract code into your EOA at the start of the transaction execution, and at the end, it resets your EOA back to a normal EOA. This is very interesting. Yeah, we can discuss about it whenever you guys want, maybe on another talk.
Yeah, definitely a cool subject for the next one.
Yeah.
Cool.
I just wanted to comment on what you said. You said you're referring to native account abstraction. So everything on ERC on Ethereum is not native account abstraction. There's actually quite a big discussion recently between EIPs. EIPs is one of the co-authors on ERC 437. So it's EIPs, Christoph Grasov, the guy from Pimlico, and Roturosh, and a few others. They co-authored ERC 437. And there was a discussion from the Ethereum community, from a select group, that said, why don't we look at implementing it at a protocol level? So they are working on a project. They're using ZKs and some other different kind of methodology, but nothing is there native. But the native account abstraction is either like a ZK sync, which means your smart contract account gives you all the functionality that we've spoken about, or like a StarkNet. And there are also one or two other blockchains that now have native account abstraction, but not Ethereum.
Yeah.
Thanks for clarifying. Other questions?
Hey guys, yeah, I'd have one question. Obviously, account abstraction is something maybe slightly new for some of us in here. So I would, well, first of all, thank both of you for such a nice presentation on this subject, and wanted to ask each one of you, what's your favorite account abstraction wallet application, and maybe what you would recommend to start with eventually. Thank you.
Sure. You mean account abstraction, wallet, or dApp, or whatever project?
Yep, pretty much any.
Yeah, I do like a lot. There is this account abstraction wallet, Empire. It's called Empire. They have a very nice UX. Also, I have a nice project which I wanted to quickly demo after the talk. One is a personal project which I'm working on with a friend of mine, Gabriel Stoica. He's also here. And the other project which I wanted to quickly demo was a dApp I used with account abstraction, and I liked it a lot. So if you guys have time, I can do a quick 5 minutes demo after this.
Sure thing.
Yeah.
But
I'll just say, in terms of account abstraction wallet, the phrase account abstraction wallet breaks it down into two categories, because we have certain smart contract wallets, like Gabi has alluded to, like Empire, like Agent, if you like the French pronunciation, Agent, that have already implemented quite a lot of good functionality that's almost paralleled what we have with ERC 437. Remember, ERC 437, you have the bundler, brings transactions together, you have the paymaster, sponsor transactions, you have the entry point to verify those sponsor transactions, you have the user account, which means you can get more kind of variables and data into your original transactions. Some may argue it's more like a struct, and so on and so forth. So you have that category of wallets. Then you have some wallets which are now implementing ERC-437 and becoming ERC-437 compatible. So from the ERC-437 original boards, they're called Infinitism. They have a wallet called Trampoline. It's very bad. I tried to use that Paris. It just was not compiling. It wasn't working well. You have Unipass. Unipass have a hardware and a software wallet. These ones are ERC-437 compatible wallets. They're slightly different from Account Abstraction wallet because Ambaya and the Argent have not implemented ERC-437. They have similarities in terms of functionality. So you have Unipass, you have Safe. I don't know why Safe decided to have a wallet because they already had similar kind of functionality. But I would say my favorite at this point in time is probably the Unipass because they've taken the best of hardware wallets, the best of software wallets, they've fused it together, and it's ERC-437 compatible. There's others that are there in the pipeline in beta, like Candice and so on and so forth. But would I recommend anybody use them at this point in time and risk your tokens? I would probably say no. So I'll go with the Unipass one at this point in time. But Argent is a pretty good wallet in terms of just general account abstraction wallet, but it's not ERC-437 compatible. They're trying to make it ERC-437 compatible now. I'm not too sure why, but
Yeah, thanks so much. Actually, I saw you mentioning on the ETHCluj Telegram group the Empire and Argent. But yeah, that's all good advice. Actually, guys, just a small favor from you to ask if you can share these thoughts. I mean, your favorite, wallets on our Telegram channel. That would be great as well, because I think a lot of us can benefit from this. As for the demo that we were just talking about earlier, I think this could be a good topic for one of our follow-up meetups, if that feels right for you guys.
Yeah, sure.
Okay. Thank you so much for your answers.
Thank you. Okay. So you guys are saying to like do the demos in another call, or?
If it's just a question of like 5 minutes, sure, why not? But if you want to maybe like go through it a bit in more depth,
No,
maybe.
It was just, yeah, a quick demo, like 5 minutes.
Oh, go ahead. Why not?
Yeah, sure. Okay.
Then maybe we can follow up with more in depth if that feels right.
Yeah, sure. Okay. Yeah, so let me actually go to, oh no, this is good. Yeah, so this is a quick demo. Like this is called Entrify. This is a project I'm working on with Gabi Vasile, which I mentioned earlier. He's also here. And this, we are basically very early in working on this product. The end goal is a single point app of like managing all your smart accounts from all the possible smart account providers. You can see here I'm connected with my MetaMask wallet, and I have added or imported or created some smart accounts, and I can easily manage them from here. And for example, I can go and add a smart account, and I can just create a smart account from here, or I can go to import, and this should search all the smart accounts from my EOA, like from different providers. For example, for Safe, it has found that I have deployed all these smart accounts which are not already here in this table. So I can go ahead and import them, for example. And for Bioeconomy, it has also found a smart account. So yeah, I can go here and I can import them. And for example, I could go to the smart account page. And here we don't have a lot of data because this is on Sepolia right now. So we can't really read a lot of analytics or anything. You can see this smart account does have a user op executed. So we have a user operation history. we can easily deposit or withdraw Ethereum from the smart account. And here at the right side, if you have tokens in your smart account, they will all show here with like percentages of if the token is up or down, and actions like receive, withdraw, swap, and so on. And we also have this page with dApps. Right now we only have Uniswap and Liquify, and they don't really work right now because we have some bug which we have to resolve. But the idea is you are connected, like you switch to whatever smart account you want, and you can interact with any dApp that supports smart accounts directly from this platform. So you can do swaps, you can do anything you want. Yeah, and this was a quick demo about this. And another project which I really like and I want to show you guys is EAC, and this is using the Bioeconomy SDK and the Bioeconomy infrastructure. So I have my EOA connected, which is this address with 9A6 at the end. But under the hood, this project, it's using account abstraction, and my EOA is actually using a smart account. So you can see here, like this platform basically allows you to buy parts of NFTs. For example, there is this NFT here, and you buy tickets, which are like parts of this NFT. And the more tickets you buy, you have a higher chance to win this NFT on the lottery. And let's say, I buy this ticket from the NFT, I have to sign this transaction. I don't need any Ether in my EOA because this transaction is being paid with USDB, which is their ERC20 token basically. So I don't need ETH to pay the gas. I just need this USDB token. And if I quickly go here to my tickets and we go to activity, I can see my transaction here, right? So, and if I go to the transaction, you can see I paid $1, one USDB for the NFT, and a very small fee for the gas in USDB. And if you go a bit down and you decode this input data, you see that the method that was called to do this, it's the handle ops method from the entry point. And we have the sender, which is our smart account address. Yes. Sorry? Okay. Yeah, the nonce, the init code, which is 0x, call data, and so on. And we can actually see our smart account here. It doesn't have any Ethereum. It just has this ERC20 token. So yeah, this was it, a quick demo of these two applications. Thank you, guys.
Thanks. It would be nice to see what other features will be added to Entrify. I'm really curious.
Yeah, we have a lot of things that we want to add, but we need time and we need also some funding maybe, because we really want to get this project like to be pretty big and to be, as I said, the one single entry point to all your smart contracts, like manage all your smart contracts from one place. Currently, like Safe and Palmera DAO, there are some projects that allow you to see some analytics on your smart accounts, but they all offer you the view only on safe accounts. So if you have Bioeconomy or kernel accounts or other type of accounts, it does not see them. And you do not have all these features of like a portfolio page for your smart accounts and stuff like this. So yeah, if you guys have any feedback, any ideas or anything, yeah, if anyone has anything to say, you can say now. You can ask me or we can discuss later after this call.
It might take a bit of time to gather some feedback. So we usually do this in another section called Ethereum Think Tank, where people present their projects. So we'll get in contact. So if you want to present the project in there and whatever other ideas you have on how to continue, then you'd probably get good feedback. So people are gathering, especially for this, to give feedback to projects and to challenge and things like that.
Yeah, sure.
Yeah, keep in touch for that. Cool. On back to account abstraction. Any other questions?
Hello, yes, I do have a few questions.
Okay. Go ahead, Alex.
Regarding the alternative mempool, each provider, each smart account provider will have its alternative mempool, or it's a common mempool for all the providers?
This is a good question. I think it's a common mempool for the providers. I'm not sure, actually. This is very close to the infrastructure team. I think it's one mempool for all the providers. Well, I'm not entirely sure.
Mm-hmm. And do you know if
there is sorry, Alexi, there is conversation about having localized mempools for certain transaction speeds prior to that would serve the purpose of simulation before sending it to the main alternative mempool. One of the reasons is to deal with the type of transactions you're sending and the amount of transactions and the duration of the transaction. So if you have some transactions that are similar in nature and you have a constant kind of logic in those transactions on a regular basis, if those transactions are always going to the alternative mempool and then you're losing time, you're paying a certain gas cost or sponsored in terms of the amount of paying, there's discussions about having localized mempools. So there's a company called BlockPi. BlockPi is pioneering having alternative mempools for transactions with similar kind of logic. And these transactions will be batched together as one single transaction. So take for example, I have one transaction all for yield farming. Maybe there's 6 or 7, I batch them into one type of transaction. I have maybe 7 for some kind of token swap, I batch them into one. They will go into a localized mempool, and then we're just going to have one single transaction into the alternative mempool. So yes, you are correct. There is, as Gabi said, there is a generic alternative mempool, but there's discussions. And if you wanted to get a bit more information about it, the ERC 437 has a developer call group. They're up to about 25, series 25. This is core development from the Infinitism group. So it's the core development they're doing. And they will give you discussions about in-depth work where they are. So the last time I attended, I think it was probably series 19, they were actively talking about having localized mempools.
Okay, thank you. I need to research more on this for sure. And I guess this alternative mempool and the bundler are centralized points, right? For now, at least.
Yeah.
Yeah.
If you,
the bundler, there's a test suite for bundlers. There's a test specification all bundlers need to pass.
yeah.
So the bundlers are operating off-chain, the off-chain. If you classify off-chain as centralized, then if that's the phrase you want to use, they generally don't say the phrase bundlers are centralized, but bundler can simulate transactions off-chain before the final transactions go on-chain.
Yeah,
so,
to check if the transaction will go through.
Yes, yeah. But there is a level of decentralization. So I would probably go with hybrids, semi-decentralized as opposed to just being totally centralized.
Yes, they are not totally centralized because the validations are done on-chain and off-chain. But if you ask a very degen guy from web3, he will say they are centralized, and that's why the end goal is native account abstraction in the end. I shared a link in the chat if you guys want to have a look on. If you want to dive in account abstraction, this is the best repository you can find.
The Zoom chat or the Telegram?
In the Zoom chat, yes. Can you see?
I'll also say to everyone that there's a lot of information out there about account abstraction pitched at different level. I have a meetup group which will be pitching discussions at different levels. So there will be definitely technical, very technical discussions for individuals who are just building directly with, for example, 6900 or 7702, or as the case might be, but also more of tackling it from an executive level and an investment level, and looking at what maybe just generic applications are looking for and how to implement it, and some of the pros and cons. So if anybody wants to come, you're more than welcome. Come to the meetup. And if there's any topics you would really like to see, then we can pitch them and have a conversation about it.
Cool. Thank you, guys. So definitely keep in touch. And if there are no other questions, then we can call this meetup. Really nice presentation. Thank you very much. Thanks everyone for joining, and see you next time. Keep in touch in Telegram.
Thank you, guys.
Thank you, everyone. Thanks for attending.
Bye-bye.
Thank
Bye-bye.
you. Bye-bye.